Good evening. In this presentation, we will show our present work about automatic fake news detection in the Twitter social network by using a data mining framework based on explainable machine learning techniques. This work has been developed by the Chilean researchers Eduardo Puraivan, Eduardo Godoy, Fabián Riquelme, and Rodrigo Salas. As a brief contextualization of the problem, it is well known the importance of online social networks such as Twitter for communication and the rapid spread of content, especially in crisis situations. However, despite the advantages of the social networks, their negative use for manipulating information and installing fake news is also increasing. The rapid viralization of content is at the same time an obstacle to the automatic and real-time fake news detection. Thus, fake news detection is currently a problem in continuous and growing development. Villa proposed in 2018 an information ecosystem that presents the process of creating fake news. Although the motivations to create fake news are frequently related to economic or political issues, fake news can also be shared due to biases or ignorance, contributing to the phenomenon unintentionally. The type of content is diverse and can be satire or parody, misleading content, imposter content, or fabricated content. The elaboration of fake news requires framing a new item, packaging it, determining its scope, among other aspects. Finally, fake news are spread through several media, such as television, newspapers, or social networks. This work focuses on the spread of fake news on the Twitter social network, as it is a mass news spreader source. Now, we will explain our fake news automatic detection approach and what are the hallmarks of our proposed methodology. We consider linguistic and network features, as well as sentiment analysis to measure polarity and subjectivity. Feature extraction techniques are used to characterize the separability of real and fake news. Finally, XGBoost is used as predictive model to identify fake news. As a case study, we use a dataset reported by Nikiforos et al. In 2020. This dataset contains news extracted from Twitter and already classified as real or fake. It also includes linguistic features related to the text of the news and network features related to Twitter metadata, interactions, and impact of the news within the network. This dataset is enriched with sentiment analysis, polarity, and subjectivity. The original dataset has more than 2,000 news stories, of which 272 are fake news. Due to this difference, a simple random sample is carried out on the real news, leaving the same amount of fake and real news. Thus, the final dataset contains 544 news items, 272 of each real and fake class. Highlighted are shown the 9 linguistic features and the 3 network features considered in this work. Variables with little variability, missing values, and those with a non-significant difference between classes were discarded. The most appropriate methodology to carry out the above is KDD, proposed by Fayette in 1996. This is because the dataset already exists, and the steps described in the feature are carried out on it. Data selection, preprocessing, transformation, data mining, evaluation, and implantation. This is an iterative and interactive process. Note that KDD can be understood as a process of identifying valid, novel, potentially useful, and mainly understandable patterns. Now we will present the results obtained. This graphic represents the polarity, see the x-axis, and subjectivity in the y-axis of real and fake news. Fake news are marked as red dots and real news as blue triangles. Polarity is on a scale of -1 to 1, where -1 is very negative and 1 is very positive. Subjectivity is on a scale from 0 to 1, where 0 is very objective and 1 is very subjective. Note that 174 points have coordinates 0, 0, which means they are all neutral and very objective news. When testing if there is a significant difference in polarity and subjectivity according to the type of news, the Mann-Whitney U-test tells us that there is a significant difference in subjectivity, contrary to what happens in polarity. For futures extraction, we use principal component analysis, or PCA. This allows obtaining new independent components, which are linear combinations of the original variables. The variables, in this case the linguistic, network, and sentiment features, are standardized before the application of PCA. This figure shows the projection of the data in 2 dimensions. By observing the length of each vector, we can see the contribution of the variable to the component. The angle reveals the correlation between variables. The lower the angle, the greater the correlation. If 2 vectors are in opposite quadrants, there is a negative correlation between the corresponding variables. Note that in the first component, the greatest contribution is given by the number of words and the number of syllables. In the second component, the greatest contribution is given by the average words in sentences and the number of short sentences. Additionally, it is observed that the 2 dimensions explain 39% of the variance. In this correlation matrix, it is possible to see in detail the contribution of each variable in each dimension. It's very interesting to note, for instance, that in the third component, the greatest loads have the network features, in this case the like count and the retweet count. The remaining loads in this component are negligible. The visualizations in 2 dimensions help a lot to the observation and interpretation of the data. In order to explore the separability of the data in 2 dimensions, we use principal component analysis, PCA, in the figure of the left, and T-distributed stochastic neighbor embedding, TSNE, on the right. It's observed that through TSNE, the news can be clearly separated between real and fake news. Although PCA and TSNE can be considered techniques to reduce the data size, it should be considered that PCA is a linear technique. It captures the global data structure. It does not use hyperparameters. It is affected by outliers, and it preserves variance. Instead, TSNE is a nonlinear technique. It captures the local data structure, the groups. It involves parameters. It has good treatment of outliers, and although it does not preserve variance, it maintains the distance. Finally, we will talk about the predictive model. Extreme gradient boosting is a fast and high-performance nonlinear technique. Its interpretability is key since the variables of greatest importance for the model can be identified. For the model, 75% of the data were used for training and 25% for testing. The precision of the model is 0.99, with 95% confidence and a p-value near to 0. The kappa index is 0.985. These results confirm the consistency of the developed model. According to the table, the most important variables in this model are the average syllables, like count, and retweet count. As a conclusion, the study reveals there is no association between fake news and negative sentiments. The principal component analysis shows a strong load of linguistic features in the first 2 components. In the third component, the highest loads are associated with the network features. The data separability through PCA and TSNE show that, considering the features mentioned above, The data can be separated according to the type of news in a non-linear way. The predictive model with XGBoost achieved 99% accuracy for well-classified news. In this model, the most important variable is the average syllables. The kappa index is 0.985. Finally, only to mention that models with 90 linguistic features are currently being developed on texts longer than tweets. Preliminary analyses show very promising results. And that's all. Thank you very much for your attention.